All right, so today we're going to talk about average rate of change, and this is actually a calculus topic, but we're going to introduce it to you guys here. And so we're going to start off with this little warm-up, and we're going to plot the points 2, -4. So I'm just going to start by plotting that point 2, -4. Let me choose a different color here so we can see this a little better. 2, -4, and 1. We'll plot the point 4, 0. These are on the graph of f of x equals x squared minus 4x. So that's a parabola. And then it says to draw a line through the points. All right. So I'm going to do that the best I can here. If I can find myself a ruler here. That is. Had one here. All right. So I'm going to draw myself a line through here. And there we go. How's that? Pretty close. All right. And then it says find the average rate of change. Well, anytime you see average rate of change simply means slope. All right? So I want to find the slope between those 2 points. So if I just count from one to the other, again, slope is rise over run. So we have a rise of 1, 2, 3, 4, and a run of 2. So the rise and the run here is equal to 4/2, which is equal to a slope of 2, or an average rate of change from one point to the next of 2. The next one says to find the average rate of change between the points 4, 0 and 5, 5. So I go over here to 5, 5. And I'm not going to draw the line this time because it's just going to get more confusing there. But if I count the slope, I would get 1, 2, 3, 4, 5, and over 1. Oh, I guess it did say to draw a line through those. So the slope on this guy would be 5 here. Okay, so I am going to draw the line here. There we go. All right. So as the points go higher on the curve, the question is, what happens? Well, we can see from the 2 examples so far, and you can see from the lines, that the slope gets steeper here. All right, as I move up the right side of the parabola, the slope gets steeper. And that would happen even if I went to the other side of the parabola, except the slopes would be negative, but they would still get steeper as I go up the left side as well. So the slope would, on the left side, the slope would be negative. As you came down, the slope would be negative. However, you still have, as you go up the left side, again, you would still have the slope getting steeper, even though it's a negative steeper slope. All right? So when we compute average rate of change, again, all we're doing is computing slope. And if I asked you to compute, given 2 points, 2, -4, and 4, 0, find the slope algebraically now. So our slope formula is y2 minus y1 over x2 minus x1. And the x2 and the y2 really don't matter, so I'm just going to take them in the order. Back again. So as we go to do the slope here, if I were to do y2 minus y1, I'm just going to do them in the order that they're shown here. This would be 0 minus -4 over 4 minus 2. And we would end up with 0 plus 4, which is 4 over 2, and we would still get a slope of 2. Now, what you want to keep in mind is that the slope formula works for any interval, okay? And remember, when we talk about intervals, those intervals are some x1 up to some x2. So when we talk about an interval, we're talking about some smaller x to some larger x. And they can be calculated for over and over for any 2 points on the graph of f of x. So I could take any points I wanted, okay? So on the interval x1, x2, so x1, x2, all right? If I take x2 and I subtract x1, okay? So if I take x2 and I subtract x1, that is going to equal some value of h. Okay? Now I'm just going to come over to the side and I'm just going to look at this interval up top here. So I had the points 2, -4, and 4, 0. So if I take the larger x2, so this would be my x1, this would be my x2. If I take x2 and subtract x1, so 4 minus 2 equals 2. That's going to equal some value of h, where h is the difference or the space or the distance between x1 to x2. All right? It's important that you understand that, you know, whenever I take 2 points on a graph, there's going to be a gap between the x values. That's all that I'm trying to get by you guys here. Okay? So as we look again at these same 2 points, all right, and I kind of already did the work for this, given the points 2, -4, and 4, 0, what is h? Okay? So keep in mind that h is equal to x2 minus x1. And so in this case, h is equal to, and again, I'll label them here. This is x1 and this is x2. So h is equal to 4 minus 2. So h is equal to 2. Now there's a reason I want you to understand that. We'll talk more about it in just a minute, but that's the distance, the horizontal distance between the points. Okay? What is the interval that we're talking about here? The interval that we're talking about is the interval from x equals 2 all the way up to x equals 4. So that interval has a distance of 2 units. Okay? So I hope that that makes sense, okay? Because we're going to talk a lot more about that h in just a minute here. So given the points -1, 5 and 1, -3 on f of x, what is h? All right? So again, using my formula, h equals x2 minus x1. So here's my x1, it's the smaller one. Here's my x2, it's the larger one. So if I do the subtraction, I get 1 take away -1, and I end up with an interval of 2 units wide again. So h is equal to 2 in this case, and the interval in terms of x would be from -1 to 1. Okay? Hopefully that makes sense. Let's keep moving on and talk a little more about this. Okay? Because this is where it gets a little bit trickier, but it's still not that bad. As long as you understand what the difference in the interval means and how to plug something into a function, this really isn't bad. All right? So you're going to see some new notation here today, and that notation, if you see this little triangle y over triangle x, this really isn't called that. It's called delta y over delta x. Okay? So this is delta y over delta x. And you're like, big deal, what does that mean? Well, delta y basically means the change in y, and delta x means the change in x. Now, you already know what this is, although you've never heard these terms before. The change in y is y2 minus y1. Look familiar? The change in x is x2 minus x1. Hopefully that looks familiar. Delta y over delta x is nothing more than the slope formula. Now, there's a different way to write this than what you're used to seeing. All right? So another way to say y2 is to say f of x2. So if I were to take some function and plug in x2 to the function, I would end up with some y2, and we could call that f of x2. So my delta y is f of x2 minus f of x1. So that's really y2 minus y1 over x2 minus x1. All right? This is what we call the average rate of change formula. It's also known to you as the slope formula. Okay? So as we think about x2 and x1, like we talked about on the other page, we're talking about the interval from x1 to x2, and we know that anytime we subtract x2 minus x1, we get some value of h that tells us how wide that interval is. Okay? So what I'm going to do here is I'm going to do a little bit of substitution. I'm going to start on the bottom of this fraction. On the bottom of the fraction, you have x2 minus x1. Well, like we showed on the other side, x2 minus x1, that equals h. That's some value, some width of the interval. Okay? Now, x2, if you look at my interval over here, this is where this gets a little weird here, but I'm going to go back to this interval right over here, up at the top. And if I actually add x1 to both sides, I get I get x2 equals x1 plus h. So again, if you think about it, if I'm sitting at some value of x1 and I want to move forward to some other value of x2, I need to add something to my x1. That's what that h value is. It's the distance in the interval. Now the reason I'm showing you this is because now I'm going to take and do another substitution in my slope formula. I'm going to replace x2 with x1 plus h. So in my formula back here, delta y over delta x, instead of writing f of x2, I'm going to write f of x1 plus h minus f of x1. And that is what we end up with for the slope formula. Looks like I have an extra piece down here, but that's okay. We're going to ignore that. Okay? What we do need to know is that h is the difference between x2 and x1, and h cannot be 0 because then I've got problems in my fraction and I end up with 0 in the denominator, and I don't want that. Okay? So we call this guy the difference quotient. That was the title of this section right up here. This is the difference quotient. All right? So if I want to find the slope of any 2 points on any graph, I can do that using the difference quotient. Okay, so back up here where it says delta y over delta x, what we want to understand is that x1 is just really any x on my graph, and the h is the distance to the next x. Okay? So I can actually write this as f of x plus h minus f of x all over h. And so in example 3, we're actually going to look at the function f of x equals x squared minus 4x, and we're going to compute the difference quotient. What does that mean to do? It means that I want to do delta y over delta x, which means I'm going to compute f of x plus h minus f of x all over h. Now, here's the thing. I don't know what h is, so I have nothing to plug in for that. I already know what f of x is. It's x squared minus 4x, so I have nothing to plug in there other than x squared minus 4x. What I need to compute is f of x plus h, and that's exactly what I'm going to do. To do this, it means take x plus h and substitute it anywhere you see an x in the original function. So f of x plus h becomes, taking out the x from the squared portion, I get x plus h squared minus 4 times x plus h. All right, so that's the first part. That's f of x plus h. From that, I want to subtract f of x. When I subtract f of x, I need to remember that I'm subtracting all of f of x. So x squared minus 4x, and then the whole thing goes over h. All right? So that's what we need to do and simplify. So here we go. In the numerator, x plus h squared. I'm going to abbreviate a little bit here just to save a little bit of space, but this is really just x plus h times x plus h. And so that's going to be x squared plus x times h is xh, plus h times x is another xh, plus h times h, which is h squared, minus 4 times x, which is negative 4x, minus 4 times h, which is negative 4h, and then I've got minus x squared at the end, and plus 4x when I distribute. That's a lot of terms on top there, isn't it? Now, watch this. We're going to cancel some stuff out here. X squared in the front cancels out with negative x squared in the back. What else do we have here? The negative 4x here cancels out with the positive 4x here. I believe that's all we have left at this point. So I'm going to combine like terms. xh and xh is 2xh plus h squared minus 4h, all divided by h. Now, each of my terms on the numerator has an h in it, so I'm going to factor out an h from the numerator. H times 2x plus h minus 4 all over h, and I'm going to cancel those two guys off right there, and I'm left with 2x minus 4 plus h. Now, so you're asking yourself, what is that? What does that mean? Okay, so keep in mind that this was delta x, or excuse me, delta y over delta x. Well, what's delta y? It's the change in y over the change in x. But yeah, Mr. Cornelius, you know, the change in y over the change in x, that's a slope. That's like 3 over 2 or 7 over 9 or whatever. But here's the thing about this formula. This is now a formula for the slope of any 2 points. Okay, this formula right here, this gives the slope of any 2 points on f of x. All right, and we're going to do that in a minute. We're going to compute some slope using this formula, and I'll show you how that's done. But basically, the difference quotient gives you a new formula that will compute the slope for you at any 2 points on the graph. Okay, so let's take a look and see how this works. All right, so we're going to go down here. We know that our difference quotient is 2x minus 4 plus h. So it says use the difference quotient to find the average rate of change. What do we mean when we talk about average rate of change? We mean slope. So to find the slope, okay, use the difference quotient to find the slope in the intervals 2 to 4, 4 to 5, and 5 to 5.2. Now we've already done 2 to 4. Okay, so I'm going to come back down here, and this is the one that we drew originally. Okay, we drew the line from 2 to 4, and we already know that that slope is 2. But watch what happens when I do this. Number one, in order to use my difference quotient, I need to know what is the value of h. Okay, so h in this first interval is 4 minus 2. So h is equal to 2. Now, what is x? The x in the formula is the first x in the interval. So when I go to plug these in, I'm not going to plug in 2 and 4. I'm going to plug in x1 and h. So here we go. Delta y over delta x, or the slope from 2 to 4, is now 2 times 2 minus 4 plus h, which is 2, and so delta y over delta x is equal to 4 minus 4, which is 0, and 0 plus 2, which is 2. And you're probably sitting there asking yourself, you know, why did we do all that? Couldn't we just find it from the graph? Yes, you could, but it's not always easy to find from the graph. Okay, and you'll find out why in just a minute. So let's do another one. Let's do the interval from 4 to 5. So the first thing I need to know is I need to know h. h equals 5 minus 4. So in this case, h is equal to 1. So I do delta y over delta x, and that's going to equal 2 times the first x value. So in this case, it's 2 times 4 minus 4 plus my h value of 1. And so delta y over delta x is equal to 8 minus 4, which is 4, and 4 plus 1, which is equal to 5. Now let's look at that interval. From 4 to 5, here's my point at 4, here's the point on the graph at 5, and there's the line between those. We saw that line already on the front side, didn't we? That line has a slope of 5. But I didn't have to do the whole slope formula. All I had to do was plug it into this difference quotient, which, yeah, it took me a little bit of time to figure out, but once I have this, I can compute the slope all over the place. Take a look at the next one. So I'm going from the interval 5 to 5.2. So h is equal to 5.2 minus 5, which is equal to 0.2. So delta y over delta x. Now, take a look at this. If I tried to graph those points, that would be really tough. I mean, we're talking from 5, so this point that I've already got up here, all the way to 5.2, I don't even know where 5.2 is at. So maybe somewhere up in this area, who knows? I'm guessing now, aren't I? But I can do it exactly using my difference quotient. So 2 times the first value in the interval, x1, that's 5, minus 4 plus 0.2, and that gives me a delta y over delta x, or a slope between those 2 points of 10 take away 4, which is 6, and 6 plus 0.2, which is 6.2. So you can tell already that I didn't even plot that point correctly, because that point isn't even 6.2 higher. So as you can see, trying to do this with decimals gets very sticky if you're trying to count rise and run. All right, so this is where your difference quotient is going to come in very nicely. Okay, and if we were to plot these secant lines, what's happening as we go here? The slopes of each of these secant lines are getting steeper and steeper as we move up the parabola. When we talk about a secant line, we're talking about a line that intersects a curve at 2 points. Okay, so that secant line is intersecting the curve down here at the bottom and up here at the red point with a slope of 2, and then the green points are intersecting with a slope of 5, and then my next 2 points would be intersecting with a slope of 6.2. So you can see that as I move up the curve, the slope of the secant lines gets much steeper. All right, I think we got it there.